Hi, let's talk about the binomial theorem today. The first question we're trying to answer here is, how do we expand the form of x plus y quantity to the power of n, where n could be 1, 2, 3, 4, any of the natural numbers. If you take a look at the question and set n equals to 1, there's really nothing further to be expanded. So we will just start from where n is equal to 2, and let's take a look at the square of x plus y. Again, this is really just a special case where n is equal to 2, and we're trying to generalize this result or this formula for square of x plus y from here to any power of n. When we calculate the square, you might have known the answer. It is actually x squared plus 2xy plus y squared. And the reason we obtained those terms is because, first of all, the square of x plus y is really just defined to be the product of two terms in the form of x plus y. Okay, so we multiply x plus y by itself twice for 2 times. Okay, so 2 factors. Therefore, on the right-hand side, each term here, see, for x squared, the power is 2. For x times y term, the sum of the powers is still 2. For y squared term, there is no x term, or you could say the power of the x term is x to the 0th. Then the power of this is also 2. So we could expect the same thing happens to any general power n here. The reason for that to happen is because when we FOIL out that x plus y times x plus y, each time we just pick one term from one parenthesis. For example, if I take x from the first, x from the second, I get x squared terms. Okay, and there is really just there are 2 x's, therefore the power is 2. Okay, each time you have to pick one term from one parenthesis. There are altogether 2 parentheses, therefore the total number of the powers, or the sum of the powers for x and y, must be 2. Okay, for the same idea, we would expect, for example, when n is equal to 4, on the right-hand side of the expanded form for this, there would be x to the 4th power. There will be x cubed times y to the 1st, because I know the sum of these 2 powers must be 4. And there will be also x squared, y squared terms, and x to the 1st, y to the 3rd, or y to the 4th. And that will be all the terms we have for x plus y to the 4th. Okay? Next, let's take a look at the coefficients. For this x plus y squared, I have x squared with coefficient 1 because there's really just one way to choose from both of these parentheses. If I choose x's, okay, these 2 x's, that's the only way I can combine those 2 to get an x squared. Okay, but please note that there are actually 2 ways to choose x from one out of these 2 parentheses and y out of the other parentheses. For example, I could have chosen x from the first, y from the second. There I have an xy. Or if I combined y from the first, x from the second, then there is another way to have x times y by the end. Since there are 2 ways of choosing such a combination of x, y, the coefficient here we get in front of x, y would be 2. Okay. So now let's try to extend this question further. If I want to find in x plus y to the 4th power, for the coefficient of x cubed times y to the first. I would think of the question as, in all those 4 parentheses, let's expand this as, we can write the fourth power as x plus y times x plus y times x plus y times x plus y. I have 4 such factors, okay? And in order to find the coefficient of x cubed y to the first, all we need to find out is how many different ways can we choose 3 parentheses out of these 4 parentheses, so that we will just take an x from each of those 3 chosen parentheses, and for the remaining parentheses we will just take a y. For example, if the chosen 3 parentheses are the first, then we can have this x, this x, this x. These 3 combined with, for the last one, I will just go ahead to pick that y. And when you follow out these, you will see 1 copy of x cubed times y. Okay, or another way to choose, if I chose parenthesis 1, parenthesis 3, parenthesis 4, then remember, for those 3 parentheses, I will take x terms there. So I could choose x here, parenthesis 1, parenthesis 3, parenthesis 4, and for the remaining one, we chose y. Combine these 4 terms, you still have x cubed y. Okay, so how many ways can we choose 3 parentheses out of 4 parentheses? And we all know that the answer is given by 4 choose 3. So the coefficient here must be 4 choose 3. Okay, where 3 is corresponding to the power of x. Similarly, you can do the observation to all the other terms and find their coefficients. Here for x to the 4th, you may have 4 choose 4. Okay, these 2 are can be added together, so this is the sum of these terms. 4 choose 2 here, because again, you take 2 parentheses out of 4 and pick x's there. For the remaining parentheses, you just take y. For this one, you just need to choose 1 parenthesis and take x from it. Therefore, there are 4 choose 1 such ways. Okay, for the last one, there is really no x. So if we stick with the powers of x, we would say the power of x is 0. So we will write the last coefficient there as 4 choose 0. Please note that 4 choose 0 is really equal to 4 choose 4. So the formula still works if you keep track on the powers of y's. Therefore, you could have written this as 4 choose 4, this as 4 choose 3. They're the same numbers. This is, again, 4 choose 2 if you stick with the power of y. This could be 4 choose 1. This could be 4 choose 0. Okay? But in order to make the coefficients formatted in a nice order, we choose to stick with 1 powers there. If we choose to stick with the power of x, this lower number here will always just agree with the power of x. Okay? Now, in general, let's summarize what we got here for the expression of x plus y to the powers of n. On the right-hand side, we would expect the terms in the form of x to the kth power times y to some other powers where their sum is equal to n. So if I set the power of x to be k, I'd better write the power of y to be n minus k. Okay, and the coefficient in front of this term is n choose k. Just as we have seen for the case where n is equal to 2 and 4. Okay, and then we will just go ahead to sum up all possible combinations of these terms where the power of x runs from 0 to n, or you can put it in the reverse order. The power of x runs from n to 0. Okay, but for simplicity, we will just please note again the k here indicates the power of x. Okay, so we will let k goes from 0 to n. So this is really the formula that led us to expand the form of x plus y to the power of n.